Perhaps you can outline what you think is the future for maritime satellite communications.
I think broadband connectivity for the maritime market is really a key market, and we expect significant growth. If you look at all of the new applications in the maritime sector, how to improve fuel consumption, IoT, the containers that are now connected, it requires connectivity all the times on the vessel. And we expect that this is going to keep growing. We have estimates that the market is going to grow from 280 million right now to 500 million in 2020. We are ideally positioned with our high throughput satellites to really cater to this type of requirements, increase connectivity and IoT connectivities on the vessels.
How much has Intelsat invested so far in maritime-facing satellites since 2015, and what is Intelsat's future investments going forward?
Okay, so I would even take it before 2015, because starting in 2009, we added on our replacement satellite wide beams that were covering the vessels, the maritime routes. And we decided when we did the next replacement satellites that we needed to provide even more throughput for these main routes. So we decided to launch our high throughput satellites. It's a total of $2 billion investment. It's 7 satellites. 3 satellites are already launched, and then we have 4 more going.
Do you have a date for the 4 more which you suggested there were going to be launched?
So the last one is going to be launched at the end of 2018. So we launched, most recent one was launched last week, and then we complement the launches with one which is going to be over the Pacific, which is called H3E, which is going to be launched toward the end of 2018.
Can you give us an update on the EPIC launch and commissioning program, please?
So 3 satellites that are operational today, IS-29, which was launched January 2016. Then we had IS-33, which was launched in August of 2016. And then the most recent one, IS-32, which was launched in February this year. So what that means is you already have 1 satellite which is covering Latin America and the transatlantic. You also have 1 satellite which is IS-33, which covers Europe, Middle East, Africa, and part of Asia. And now you have a second satellite which was launched last week, which complements on the transatlantic fleet the IS-29. On top of that, it also covers the Caribbean. So we really try to cover multiple applications. It's not only maritime for the commercial, but it's also when you put beams over the Caribbean, you can also target the cruise ships.
Now, what is the importance of broadband communications on shipping and other maritime users?
I think right now we are really in the world of computer, iCloud, and so on. It's really around being connected all the time. It's IoT application that we already covered. It's also broadband for not only the passengers, but the crews. And we needed to provide this type of connectivity for the customers all the time. So it's the application, again, how to optimize fuel consumption. It's also the service to the passengers and also to the crews.
What applications does EpicNG open up for the maritime users?
It's really a way to provide the same type of service as the ship owners have on the ground, also when they are traveling between ports. And all of the optimization that we have already discussed will be key for them, not only to look at how do I provide the connectivity to the passengers, but how do I optimize the use of my fleet.
What do you think is the future demand coming from for maritime broadband?
So right now what we see is at a passenger level, we expect that connectivity is going to be well above 512 kilobits per user. So we really expect this is going to keep increasing. The same way you have connectivity when you are on the ground, that you expect more connectivity, you are going to require the same type of connectivity when you are on a vessel. At the same time, for all of the IoT and additional application, you are going to require more and more connectivity, and there is going to be more cloud computing, which is going to be in place. All of that requires passengers and also the vessels to be connected all the time.
Why do you think that people should choose KU band over KA band?
So at the end of the day, the band is not really what matters the most. Of course, there are differences between the different type of band, but it's really about being connected, and it's also how you have open system versus closed system. We decided to design our new high throughput fleet based on the reuse of the existing equipment from our customers. So our customers can easily switch from a high throughput type of connectivity with some areas that are going to be covered with wideband, reusing some of their existing teleport investment. So at the same time, we really see differences between KU and KA in terms of rain fade, which is important for some of the maritime market. So overall, it's not about the band, it's about having the ability for a customer to move from their existing infrastructure ability to grow in certain area, moving from wide beam to high throughput beams.
Do you think there's still a future for C-band, though?
There is a future for C-band, and again, it's the same question around the band. There are already a large number of vessels that are equipped with C-band, so we really see that as being complementary. Everything is not going to switch to high throughput. There is going to be a mix of C-band, KU band, wide beam, KU band high throughput. There is going to be L-band also, and this is going to meet all of the demand of the connectivity on the vessels.
What comes beyond EpicNG? Is it going to be more NG satellites, or are you going to go for higher bandwidth in a different band? So, for the moment, we are in the phase of deploying EpicNG, and we expect, like in a lot of other applications, that the demand is going to keep growing. At the same time, we see that there is even more optimization that can be done on the ground that provides more throughput. So one of the things which is clear with EpicNG is you have an increased performance. So right now, without changing the equipment, we see increased performance of 165% versus what customers were doing before. If you start changing the equipment, you see even higher performance improvement with up to 330%. So we expect that our customers will have the ability to, even on top of getting additional performance on the satellite, getting additional performance with ground equipment, which is going to help them really monetize in the best possible way the use of the capacity. We really look at it as it's all about performance, it's all about accessibility also, and we do a lot of effort on how do we make it easier for our customers, the investment that we do on Kaimeta or on Phasor, how to reduce the size of the terminal, which is going to make it easy for our customers to deploy on more and use more capacity. So, of course, we are thinking about what are the changes that's going to happen on the satellite and how we can even optimize more the use of the satellite and how we deploy next generation of satellite after Intelsat Epic. But we are really looking at it as in a much broader way. What are the innovations on the ground that we can make?